This video is about using coordinate notation to dilate an image, identify the scale factor of a dilation, and construct the center of dilation. So a dilation is a transformation that alters the image's size, but not its shape. So if it's a triangle, it's still a triangle, but it might be a smaller triangle or it might be a bigger triangle. So we are going to either enlarge or reduce the size of our shape. The image is stretched or shrunk with respect to a fixed point called the center of dilation. So when we are doing a dilation, we can look at scale factor or similarity ratio to help us change our size. So what's going to happen here in the scale factor is we have our image over our original. Another way to think about this is new over old, whereas similarity ratio is the old compared to the new. So they are reciprocals of each other. So for now, we're going to identify the scale factor. So looking at the two owls, we have one owl that has a size of 8, one that has a size of 3. We want to do the scale factor. So our original is our old, and our image is our new. So we would have the size of the new over the size of the old, which is 3/8, and that does not reduce. And that should make sense because we went from a larger to a smaller. So our scale factor is going to be less than 1. In number 2, we have two ships. One has a size of 4, one has a size of 6. So remember that our size of 4 is our old, our size of 6 is our new. So we have 6 over 4, and that reduces to 3 over 2. In our last one, we have the pirate smiley faces. So we have one that's a size of 1, one that's a size of a fourth. The old is 1, the new is 1/4. So we have 1/4 divided by 1, which is just 1/4. So in our dilation here, when we are dilating at the origin, we're going to plot our points of our given shape. So A is at 2, 4, B is at 4, 4, C is at 4, 2, and D is at 1, 2. Then we're going to dilate with a scale factor of 2. So that means that we are going to multiply by 2. So every coordinate is going to multiply by 2. So 2, 4 is going to become 4, 8. So that's going to be A prime. B is 4, 4. When we multiply by 2, that becomes 8, 8 for B prime. C is 4, 2. And when we multiply, that becomes 8, 4. So that's C prime. And then D, when it's 1, 2, that becomes 2, 4. So that is D prime. So a way to show that in coordinate notation is we're going to take our x and our y and we're going to multiply them by 2. So it's going to become 2x and 2y. So using the given dilation, we're going to change our figure here. So in this case, we have x to y changes to 3x and 3y. That means here we have a scale factor of 3. So we're going to multiply our points by 3. So let's find our original points first. So G is at -1, 2, U is at 2, 0, and M is at -1, 0. So when we multiply everything by 3, we get -3, 6 for G prime, 6, 0 for U prime, and -3, 0 for M prime. So now we can plot our points and label our letters and connect them together. So notice because the number was greater than 1, our shape got larger. In number 8, we have x to y changes to 1/2 x and 1/2 y. So this time our scale factor is equal to 1/2. We should expect our shape to get smaller because it's less than 1. So if we write down our points, C is at -4, 2, A is at 2, 6, and T is at 8, 4. When we multiply by 1/2, we get C prime is at -2, 1, A prime is at 1, 3, and T prime is at 4, 2. So when we go to graph those, we have C prime, A prime, and T prime, and then we can connect our shapes. Okay, and just as we wrote above, our scale factor for the first problem was 3. Our scale factor for the second problem was 1/2. Number 9, a dilation maps from 5, 4 to 15, 12. What are the coordinates of the scale factor -2, 3 under the same dilation? So first we have to figure out what our scale factor is. So what did we multiply to get from 5/4 to 15 over 12? So if you're not sure, you can just take one of your points, 15 divided by 5, which gets us a scale factor of 3. So that means we multiplied by 3. So in our new point, we're going to multiply each of those by 3. So we get -6, 9. In number 10, we went from 10, -15 to 2/3. So we need to figure out to 2, -3. So we need to figure out what we multiplied by. So in this case, our scale factor, we're going to take the second number divided by the first number. 2 divided by 10, we multiplied by 1/5. So we're going to multiply each of these by 1/5. And we should get 5, -1. In number 11, what is the image of the point -8, 6 after a dilation of 2 to 1? So this here is a similarity ratio. We want the scale factor. So to get our scale factor, we need to do our reciprocal. So if it's 2 to 1, our scale factor is 1/2. So we're going to multiply each of these points by 1/2. So we get -4, 3. In number 12, again, we have a similarity ratio of 1 to 5. So our scale factor is 5 over 1. So when we multiply each of those numbers, 12 times 5 is 60, and -3 times 5 is -15. In number 13, ABC is dilated to DEF. So we went from ABC to DEF. So we went from a larger to a smaller triangle. So this is going to be a reduction. For our scale factor, remember it is always new over old. So 10 is the new, 14 is the old. So we have 10 over 14, which reduces to 5/7, which should make sense. If it's a reduction, we're getting smaller. The center of dilation. So we see these dotted points that are going to this center point. Remember, if this is the X and the Y axis, that our center of dilation then is going to be the origin at 0, 0. In 14, we're going the opposite way. We're going DEF to ABC. So this time we got larger. It's an enlargement. Our scale factor, remember that we want new over old, so 12 over 6 is 2, which should make sense. It's larger than 1 because we're getting bigger. Our center of dilation is still going to be the same of 0, 0.